the recording. So session is being recorded. All right, everyone, good morning. Just to let you know, from now on, I'm looking at a screen here in front of me, and the only thing that I can see is the same screen, the same thing that you are looking at your computer now. I am looking at it here. I'm just saying this because in case that you have any question or you raise your hand, I'm going to interrupt, go back to the Milo screen and check what's going on. All right, so everything is being recorded. You can access this information later on. I'm just telling you how we going to proceed from now on. Make sure that if you have any question, if you want to participate, just do it. All right. This is a very different way of teaching and learning in terms of interaction. So I don't want you to be bored about this lecture. Okay. All right. So we are going to start the lecture today talking about the topic that we're going to approach. Today we're going to talk about manufacturing, planning, and control. Although this is a more generic view in terms of, let's say, production, and those who had a chance to attend KIT710, they had a more deep dive in the topic. I'm taking care about using the deep dive because we didn't go in detail in that unit as well, but there we had a reason to explore it because we were thinking about the architecture of the system. When we speak about manufacturing in e-logistics, the most important thing that we have to have in mind is probably the flow of information that we need to get from and to make sure that the logistics in the real world works. Other than that, there is no concern about understanding manufacturing, but there is a concern about understanding how manufacturing can impact us as e-logistics professionals and how we can affect manufacturing as well. So this is going to be the main focus of the lecture today, and I'm going to try to give you some practical examples to make sure that you have in mind what to expect in the real world. All right? So these are the three main areas that we're going to talk today. We're going to give an overall view about manufacturing. We are going to talk about manufacturing planning and control, and this is where we're going to. The first one, manufacturing, I'm going to try to give you a more top-down view. For example, what happens on the working floor in terms of information flow that can affect us as e-logistics professionals. And the second part, the manufacturing planning and control, we are going to approach something related to the top-down view, where you are dealing with the master plan of production and things that needs to be considered and how that reflects the planning of e-logistics as well. Last but not least, we are going to talk a bit about the efficiency using just-in-time. Not exactly explaining how just-in-time works, but making some questions and criticism about the model. How can we apply it? How we cannot apply it? Why is it useful sometimes? Why it is not useful other times? And this is what we're going to do. All right? So moving forward, if we start with the main definition of manufacturing, we call manufacturing in the theory as any part of organization's operations which transforms a resource. In this case, manufacturing is like adding value and changing something from its original state. For example, if you have a bunch of oranges in your warehouse, and you squeeze them and make orange juice, you manufacture that because you caused transformation in that. If you put them inside a bottle, you are also changing that product, adding value, not actually changing the product, the juice per se, but you are adding value in something that will later on be sold as a product. But on the other hand, we have to consider also that manufacturing is the act of moving something. We call that actually transportation in terms of the physical use of the mode of transport. But in the manufacturing approach in e-logistics here, we will be looking also at the services that are provided. Manufacturing should be committed to, I think this is obvious to everyone, to efficiency, high performance, waste minimization, and sustainability. I would say that these are areas that everyone by logic is concerned about. This is something that every single manager, every single employee must make sure that they can achieve. But the most important thing that I would like to emphasize here is that there might be a balance between them. And especially when we speak about sustainability, which is quite in vogue nowadays because of all the problems that are happening all around the world, not specifically talking about what's going on with the coronavirus, but in general. There was a lot of discussion in the past and still nowadays about like how efficiency and high performance conflicts with, for example, times that people need to work, conditions of work, which is related to sustainability. As I said before, in this unit, we're going to give you information about manufacturing, but we are going to talk, first of all, how that affects us as e-logistics professionals. All right. This diagram here, I want to talk about it, telling you the top-down approach. All right. So when we are talking about manufacturing, information technology, and e-logistics, as I said before, there are two main approaches. The top-down, which is related to what happens in the ground floor of the factory and affects the whole supply chain until it gets to the final customer. And the bottom up, which is the inputs that, this is the bottom up from the floor to the top of the organization and the customer. And the top down is the one that deals with data that comes from customers and are translated later on in plans and production activities that will reach the ground floor of the factory. All right. So speaking about this specific one, which is the bottom up, we're coming down to the top. When we speak about systems and technology that are involved in manufacturing, we might be talking about different levels of and layers of information. And I want you to understand this here because this is quite important for you if you are, for example, a professional that is later on working in process design, working in system design, working in testing, working in implementation of systems that will be used for the whole organization or that will be used for an application like transportation or whatever. These layers that you see here, data, up transmission, technique, support, platform, core platform, and functional modules, application access. When we are talking about them here, I don't expect you to understand this in detail, but I want you to keep this in mind. Pay attention now. When we talk about this level here, the lower level, I'm talking about every single device that is used to collect information. When I talk about this level here, this layer here, I'm talking about RFID antennas, I'm talking about barcode readers, I'm talking about OCR cameras, every single device that generates an information. And in this layer, you don't actually have any work with this data. You don't have any special treatment of the data. This layer here talks about the instruments and devices that are used to collect the data. So here I have some, how can I say, specifications in terms of type of message, content of the message, and things like that. And these devices, they send the data to the next level. Probably here you're going to find exactly the first layer of systems that will deal with the data. For example, if you have a barcode reader, in this layer here, you might have a system designed only for the barcode reader that will collect that information that is coming through the reading of the lasers and the barcode and say like, this is product, this is information X, Y, Z, and I am going to send this information to the other layer here. I'm going to change just for a second. Yeah, I think this image is better. Let's say in here you have the process control layer where you collect the data and you gather this data in terms of making sure that the device being used is collecting what it is supposed to collect. Again, RFID information, barcode, OCR, or whatever. There is a second level where the data that you acquired is put it together in the system. And from that, this information is organized and sent to the other layers that we have. For example, data from an RFID system can come through this gateway here, which is the system that collects the whole data of the readings, and being transported, for example, to a layer where the information is organized, especially in terms of timestamp and the sequence that it has to be presented to the users. And later on, all this data is presented to the ERP, where things will be consolidated in terms of quantities or in terms of batches, in terms of any other information that is important for you to make decisions or to manage your process. The reason why I'm trying to emphasize this is because the bottom-up approach, it's very important for those who are engaged in the design of the process. Design of the process. Because here is the moment where you're going to be able to understand what type of information is being generated, who. And when I speak about gate 1, gateway 2, gateway 3, I might be talking, for example, about different producers. I'm going to give you one example. If I have a crane in a port, in a seaport, this one might be the gateway talking about the sensor that measures the weight of a container. This other one that can be related to a sensor, to a camera that records what's happening under the crane. This other one can be reading failure detection on the crane. So every single piece of information is generated by a different system. They use different languages, different formats of information, and all of that is included in one single equipment. Important to say that most of the time, these equipments, they are protected by a firewall. You don't want anyone from outside accessing your equipment. But as I said before, although the information is coming from the same place, it is necessary that in a moment, something inside your system is able to put them all together and make sure that it is transmitted according to what is necessary for those who are using the information later on, including people from supply chain or transportation or whatever. If that's not clear yet, I want to show you one very simple and very simple example about details of information. All right, like let's say the number of information or the detail of information that you generate when you are dealing with the system. If we think about this layer here, yeah, like you had the information already created by the devices, you made them together, and you want to use it as a manageable information. I made yesterday a very simple example here about, let's say, mask production. If you are a manufacturer of masks and you want to later on have the track and trace of things that were produced by you, you might need to establish, for example, in a message that is transmitted across your system, basic information such as timestamp. So this is, if you produce one mask or a batch of masks, you are probably interested on knowing the timestamp when that was produced, the production unit that was responsible for that. Let's say I'm a large corporation and I have units all over around the world or all around the country. I want to know which was the units that produced that, in which line. Here I created the code medical health equipment 01. So if I want to track and trace where that was produced, I can know exactly which line of production made that, which machine, who was the user responsible for the operation of that machine by that time. Oh, sorry. I can have a sensor that tells me, for example, that do, let's say, infrared reading I'm making up this now, to detect defects and automatically tell me if there is a defect or not in terms of quality check assurance. And on top of that, I can have also information that describes to me what type of defect. The information about the batch, and let's say I can have also information about each one of the masks that I'm producing. What I'm telling you here is something that happens when you are, for example, designing your system and you are interacting with people that represent other systems, and they are telling you exactly what they need to operate according to the main plan that you have for your production line. Few things to pay attention in here. When you design this, you have to make sure that the system knows the difference between this and the other one here. You have to make sure that you have clearly defined the format of the message, what type of characters you're going to accept in it, what type of code, spaces, and things like that. And in addition, let's say like you want to know additional information about what's going to be included in the message, in the package of the message, you can also add this here as well. This silly example here is something that every single person working with information management in production, in manufacturing, needs to take care about. Although looking at it here now, it looks very silly in terms of quantity of information provided, but you cannot imagine, or those who had experience working with that will understand, like there is a lot of things that happen in here. Trust me, if later on the system receives something like this, which is not capital, and it was not defined in the communication process that was accepted, you're going to crash everything down, and you're going to have problems managing your flow of information. The same thing happens, for example, if you have a code for quality control assurance. Um, Once you want to track something back in time to know what was the problem and who was responsible to release that material, only if you have, for example, the user logging in the process in the machine, you're going to get this information. But how can you? Yesterday there was a question about how can you make sure that the RFID tag that is on the truck doesn't leave the port without the person without the port people knowing that an RFID tag was leaving. So you might create, for example, interlock systems where only after the person logs in the machine starts to work. Because this is important for you later on if you want to make sure that you have all the information necessary for your manufacturing management process, but also for the other parts involved in your process. I would like to know if someone has a question about this, if it's clear, if it's too complicated. I just wanted to share an example with you. No? All right. Let's move forward then. Okay, if we are talking about manufacturing planning and control, the vision that we must have in mind is integration of supply chain process. As I said before, we have to be concerned about that from bottom up, upstream, and from top down view. These views, they are completely different. You're gonna see that the level of information that you do when you manage the bottom up, it's much more technical in terms of the content of the messages, the way they are transmitted, then if you compare with the top down, where you are dealing with macro data, and you are basically using that for planning. But in the end of the day, there will be a moment that both information will get together because someone or something will need to work on the transformation of the product. And this means that the plans that were made with macro data and the information that is given from the bottom-up approach, they have to match together to make something like a factory work. It's important to say that the planning process looks at the overall coordination of movements and capacity, and this is where you have the biggest clashes inside organizations because people from planning, they tend to be very optimistic and think like, yes, we can do it. When people from the technical area, they seems to be more realistic because they're gonna say like, well, okay, whatever you're planning now works very well in an Excel spreadsheet, but if we go into practice and look at the machine, the way the machine works, the way the messages are created, you're going to see that this is not that easy to do. The most important thing, both views, they have to be aligned. And it's important to make sure that these things are under your supervision with this view. Many of the companies, they don't have that. And I'm not here to blame them to say like they're right or wrong, they are competitive or not. I'm here to say that some of them have technical restrictions. For example, if you want to make sure that the information about from the bottom layer is reaching the upper level, you have to make sure that you have like servers that support this information exchange. You have systems like OPC servers that can get that information and manage everything according to what you expect. And honestly, these things, they are expensive. They demand people to care for the operation and the maintenance, and some maintenance, And some companies, they just don't have that. So I'm not here to say that the problem is with the management of these companies, but the problem or the restriction might be related um, to the financial or workforce restrictions that they have. And this is where e-logistics professionals, they are necessary, where they come in place. Otherwise, we wouldn't have any use in this market. I want to show you, I will give you later on an example of these two. I'm going to share with you these links later on. But I want to give you one example. It's a short video of 4 minutes about one solution that was proposed by, it is proposed by Samsung in terms of integration of these two top and bottom levels. When we talk about the process in manufacturing responsible for managing information of these processes, we call them Manufacturing Execution System, or MES. So MES is a solution that is sold, and it's very commonly used by corporations to make sure that all this information flows through all the levels of the organization. I'm going to play the video here, and I hope it works well at this stage, and I will come back to you in a second.
Complex traffic lines and manual labor on production sites lower efficiency. Also, it is difficult to get real-time information to counteract varying production requests promptly. Even if we could collect different data generated from various facilities, it is difficult to decide how to put it to good use. There is no choice but to react post hoc, even though the facility breaks down. To address these issues, the Smart Factory solution incorporating ICT technology into manufacturing. Samsung NextPlant MES is the answer for you. NextPlant MES manages and controls your entire process of production activities, which will all resolve complicated and various issues. To improve the efficiency of a factory, a professional Samsung SDS consultant suggests the best movement of logistics using a detailed diagnosis process.
So just stopping here for a moment. This is the part where they say, like, a consultancy company or a e-logistics professional, whatever, how you want to call it, tells you what would be the optimum arrangement of your layout. This is a much more bottom. This is not a top-down approach. This is basically a bottom-up approach. And the main thing that you have to keep in mind here is that the process design, the process map, is one of the things that is very important for you in terms of understanding the steps and the things that you need to define for later on deciding which kind of information, which kind of data is going to flow between these processes.
In addition, the most effective factory layouts are designed by understanding where logistics equipment and storage facilities need to be located for maximized impact. Based on this information, the best route for logistics between the processes is set, and automated logistics that monitor in real time is established, enabling optimal production environment. Once operation starts in the factory where NextPlant MES has been installed, it allows you to set and manage production standards, such as manufacturing BOM, standard information, and raw materials, and track the work inside processes and between.
Just a quick stop here. This is where, for example, you have the identification of each process and each machine, and that later on, this information will be included in the sharing of the data across the process.
Processes. Real-time condition data provided from each facility enables you to determine the optimal production facility in real time to maximize performance and productivity. Namely, choosing the types of products and quantity that are to be produced, the type of facility, and the process to be utilized. NextPlant MES reflects real-time conditions of the facility to quickly discover the optimal operation while responding to your customers' demands immediately. Then how can you quickly collect and analyze all of the data generated from each facility? Nextplant MES provides facility automation solution, standardizing and collecting a variety of data from all of the facilities remotely and automatically. This enables you to standardize massive data generated from your entire factory and compile it to form a complete picture. If you are concerned about cost, attaching an edge device only to the core facility allows you to manage it separately. Nextplant MES Edge device enables easier application of Nextplant MES to small-scale industry manufacturing, making analysis easier and reducing analysis time due to standardized and visualized data. The data gathered enables you to find the root causes of endemic issues such as product defects or repetitive facilities malfunction. With modeling technique using Samsung SDS's Big Data Manufacturing Analytics. Samsung SDS has 30 years of experience in developing solutions and know-how of establishing smart factories, achieving remarkable results in installing Nextplant MES to large-scale advanced manufacturing. And now, we are expanding business areas for Nextplant MES, so it can be utilized in small, medium-sized manufacturing.
I'm going to stop here because I think now they're going to talk about a lot about the good things about the system that they sell, and I don't want to do any advertisement for them. But the other example that you have here, it's related to a more specific use of MES, Manufacturing Execution System. If you want to watch that later off, or if we have time later on, we can come back to it. What I wanted you to have an idea here, it's how these things in practice work. And this example is one of the few that I can tell you that although it seems very nice, the pictures and the views that they show in the video, this is exactly how a very good, a well-developed system works. Like you really can have a view of your machines, of everything control happening in your production floor. But again, the MES and the bottom-up approach talks about execution of the manufacturing process. This is not about things that you can plan or things that you can design or forecast. This is basically the information that is being generated to be used later on by those responsible for planning and control. All right, moving forward, what challenges, according to the theory, we have to manufacturing, planning, and control? The firms, usually, they are successful developing the system, especially when they can integrate that within different departments. For example, if you are a professional working with finance and human resources, if you have quite, and people from KIT710 heard that in the last time we spoke about this topic in that unit. If you are able to do this integration in terms of, for example, cost control centers, saying like this unit inside my plant, let's say in a beer in a brewery factory, the beer factory, if you want to control, for example, how much you are spending on bottles or the bottling process, if you have the control of that part of the process, that machine responsible to clean and put the bottles on the conveyor belt that later on is going to be filled with beer, if you can make that linked to a center cost inside the system, as the process develops along the time, you're going to be able to understand exactly how much bottles, how many defects, how much water you're using to clean the bottles or whatever, collecting every single piece of information in one cost center. In some organizations, this might not be easy to do like that because you need to have input, human input in the data that you are generated. But anyway, once you have it integrated and consistently organized in the cost centers, you are able to have a much more efficient process in terms of analysis than other companies that try to later on put together reports, Excel spreadsheets, and consolidate data that is generated separately. Question for you now, just to have a bit of your participation. The things that happen inside the organization are easier to manage. Why that becomes a problem when you're talking about integration with partners that you have around your company? Why is that a problem sometimes to integrate processes that happen with to get align this process with your partners? If you need to share the information with partners and to make sure that they use it, why that becomes more challenging? Yes, correct. One of the main reasons is exactly this one. As I said before, information collected by different players, they can be set in different formats and being managed by different systems. That's one of the main reasons. All right, thank you for that, because I think the message was delivered accordingly. As I said before, if you use your timestamp label with this format here, and your partner uses the one that put the information together in this sense, this is not going to work. All right, thank you for that. Perfect. Information is not clearly understood by planners. One thing that is quite common as well, and this is happening all the time in our lives, okay? If we look, I'm not going to mention anything specifically, but if we look at information that sometimes is written, and we think like, well, you know what? It's obvious that this thing should happen. Many times it's not obvious. Many times what is described in a text or in a set of data is not actually what people are understanding what needs to be done. And if you can expand that, let's say, to a very complex, let's think about the automotive industry. Yeah? Imagine each piece of equipment in a car that you need to ensure the right quality, the right sizes, the right everything. If things are not really clear, well defined, limits well established, quality control standards quite clear, you cannot make it happen. So this is one of the information that needs to be understood. But speaking about planners, it's also the conflict about like what the company can do in terms of planning and what the company and the machines can do in terms of execution. Thank you for that. Anyone else? All right, I'm moving forward because we're running a bit behind. So this is basically what was said in the other chat window. The main problems is complex balancing of load and capacity, coordinating market demand and supply chain reality, and things that happen inside your organization. Let's talk now about manufacturing planning and control. Now we're going to look at the top-down approach. Here, we are basically talking about ERP systems. But before we go into like ERP and all the magic that SAP and other systems can provide to us, most of the time, the manufacturing planning and control systems from the top-down view, they are originated or they are controlled by Excel spreadsheets. What I'm saying is that there is no better way to have a rough and basic forecast or planning model than using Excel. Am I downgrading the use of ERP or something like that? No. What I'm saying is that if you want to make sure that you control uh, your operation and to have the basic view of things that will happen, maybe sometimes a very basic information created in a spreadsheet can be more useful than you developing the whole system that later on will communicate with other units or other departments. But if you don't have actually the core information, the beginning of everything done, you won't be able to make that system work. So in SAP or the SAP is one of the examples here of ERPs that we have, but as we saw before, Samsung probably has its own as well, and Oracle has its solution as well. It has different modules that deals with manufacturing, transportation, purchasing, finance, and other things. This is something that is more explored in KIT710, but it's just to make sure that you understand that the role of the ERP, it's a much more top-down approach, where now we're talking about the planning of what's going to happen. We have, let's say, 3 levels, and we're going to talk about them with more detail, that constantly communicates with the ERP system. We have the planning, the resource planning, and the forecast modules that are those that gives inputs. We have that moment that I said before, where information from bottom up meets the top down, where things happen. And here you have the consolidation of data coming from planning and data coming from the machines and the ground floor being confronted. And finally, you have like the orders that go to different departments, such as purchase department, production department, or transportation department. All right? We're going to talk about them with more details from now on. So when we talk about demand management, we spoke about this before. We have different ways to forecast demand. You can have your database that's going to tell you what is expected in terms of the next months or the next seasons or the next year's production. You can have regression models, statistical models that help you to understand information about the future that you can use as your planning. Or you can have, for example, a panel of people that are quite experienced in that market and can tell you like, well, according to our view, this is what's going to happen, and this is what you should accept as your production planning for this unit. Stock keeping unit, for those who don't understand that concept, we are talking, when we talk about stock keeping unit, I'm talking, let's say, about these 2 data together, all right? Let's say if I'm talking about the batch and the individual number or identification of the product, this is what we call the stock keeping unit. This is quite useful if you are working in warehouses, because you have to define stock keeping units for places or positions in your warehouse, or in case that you have a different range of products being produced in your unit, you need to make sure that you understand, for example, if you have different raw material, where the stock keeping units are kept in your premises. Few things to understand about manufacturing and stock and planning. This is from KIT710 slides, so those who are who may find like, well, I've seen that before. Yes, you've seen that before, because this is a concept that we use for demand management. You can make to stock and you can make to order. The difference between them is that the make to stock, you have the planning in terms of minimum amounts in the inventory that later on, if you achieve that level, you will produce more for stock. And in this case here, you having feedback of the retail information is quite important because this is going to give you quite good information in terms of when you need to start acting. While if you, so again here, the integration between what's happening in the front, in the end of your supply chain is quite important to return to you to make sure that you can act. While in this case here, make to order, you only act when there is an order in place. For example, you don't produce airplanes for stock. You produce them according to orders. But what happens in here, and it's important in terms of information, once you have an order and you know which model, what are you going to be producing, you can work in terms of raw material forecast, workforce estimation, and other things that are important for you to make sure that things happen. Again, in both cases, your demand forecast will change, your operational planning will change, and the level of detail of information that you need will change as well. If you think about resource planning, this is exactly the moment that we are talking about what can be used. And this is where the conflict starts to happen between planning and operation. The resource planning is where you know exactly what is the capacity of your machines, what you can produce, and how you can do that. It's a very important information in terms of design capacity. I will make a question now for you. If we think about a production line that is able to produce 2,000 pair of shoes in 1 month, we are talking about that. In your point of view, now your opinion, when we talk about producing 2,000 pair of shoes in 1 month, what is the maximum availability that we are considering for that machine? What is the percentage of time that we expect as a planner that machine to work to achieve that 2,000 pair of shoes? What would you guess? Percentage of time that that machine should work according to your planning schedule to make sure that you can achieve that production of 2,000 pair of shoes in 1 month. Any guess? No? All right. So I will. Okay, 70%. Ugona, can I ask you why you said 70% and not 100%? Or anyone else that has a different view could add it as well. Okay, I'm gonna move forward. Just okay. I will say 100% in case of idle time. All right, because it's a small machine to produce in a month. Now, well, there is a mix of answers here that are correct. Amount of resources. Yes, thank you, Mohammed. That summarizes everything that people said on before you here. Now, all the answers are correct in terms of what you consider, but the main thing that is important here is that you have to consider in your resource planning and your design capacity the downtimes. And I'm not talking about only those that are not foreseen. I'm talking about the maintenance that you need to do in the machines. And this is where things get conflicting in terms of resource planning and manufacturing execution. So when you think about 2,000 pair of shoes for one machine, I'm not getting into the detail if it's too much or not. We're talking about the capacity in a certain level of availability of the machine. And we cannot consider that 100% all the time because you have downtimes that are planned, and some of them that are not planned, like defects or breakdowns. When we speak about this resource planning, we have to consider, for example, if our production is a discrete production where you have like many different parts that need to be put together to assemble something. So if you work, for example, in batches, where you have a production line, like a car production line, you have to make sure that you understand for how many products, different ones. Like here I have the blue and the white car. I have the chance probably to work in different models. I have to consider the amount of people, and this all needs to be included in your planning as well. Or I can have, for example, a production of repetitive goods, let's say cell phones or mobile phones, that will be the same along the time. And again, in this case, your planning will change as well, because the raw materials and the workforce that you need, it's going to be planned in a different way if you compare to, for example, a car producer or something like that. And speaking about, again, bottom-up devices and things that you have to consider in terms of information exchange in your process, you have to consider what are you manufacturing. For example, if you are making paint, your sensors, your management controls or indicators are going to be different in terms of quantities. Here we're talking about liters, we're talking about liquid cargo that will be transported in tanks probably, or small cans or whatever, which is different if you consider processed food or if you consider steel production. In all these cases, for example, thinking about e-logistics, all the transportation, all the storage, all the processes of controls of how these things are managed by your company are going to be different. So it's, again, if you put everything together in terms of general numbers in relation to planning, probably the Excel spreadsheet will not give you too many details about the controls that need to be done, but the ERP and the top layer system will tell you, like, this is how much we can produce, and this is how much we can storage or whatever. The details about how this happened in practice, you're going to get it from the bottom-up approach. And this is going to define, again, as I said, your design capacity and your effective capacity. When you think like, this is exactly what I can do in terms of putting down this machine or having a maintenance in this other one during the month, or having to wait down for these slabs to cool down in terms of temperature, because otherwise I cannot have equipment that gets close to this to collect and store it. Or in the other way, like if I have processed food, the quicker I act, the less I lose cargo, because this is a perishable production, you know. And I want to use this one to show you that different products, different processes will demand different resource planning for your corporation, for your organization. Sales and operational planning, as we spoke before in the make to stock, I think this is the main area where it is used. It's the point where sales and operations planning thinks about what we need to do not run in problems where we don't have stock or we don't have raw materials to produce what we are planning to produce. And just to make sure that this is clear, we, in this case, we need to have a more clear view of the long term, of course, let's say for the year, but this is where things start to become more detailed in terms of how many units or services we can provide per week, per hour, and things like that. So here's where we get into more details. The master production scheduling, as we saw in that Samsung video before, it's exactly when you put everything in a timesheet, in a spreadsheet where you can see the whole working in the whole process working along the time, and you can have a clear view about the logistics and the logic of the process, like how are they conflicting or how are they working together in line, and in which moment there is a gap, like if I don't fill this gap here, I'm going to have idle equipment and things like that. And this is quite important to consider, because this might be the moment where these people here, sales and operations, they think like everything works like magic. This is the number, this is the capacity that I was told that the plant can do, or the transportation can be performed. This is what I'm going to present to the board as our plan. But actually here, when you put that in detail, like, okay, put that in the paper and show me how the process is going to work along the time. That's the moment where you say like, oh, okay, I see here that this machine, this truck, this crane is not going to be available, so I cannot consider this in terms of my production plan for this month. A very simple example that is offered to you here. Let's say that we are planning a butchery shop forecast for the weeks, and we have like big pieces of cuts that come from the same cow, the same animal, but later on we want to have these cuts in more, how can I say, smaller cuts that will be sold to customers. Just as I said before, in this case here, you don't need any magic in terms of ERP or forecast or things like that. In this case here, a simple Excel spreadsheet can help you to understand, like for Monday, Tuesday, what is the amounts or the orders that I have in place and what I need to produce. Because as we said before, like we don't want to overproduce, because otherwise, if we have, in this case, for example, this material or these goods stocked for a long time, they are perishable, so it means that I can lose them. But anyway, when I start looking at the forecast for the coming weeks or the coming days, it's clear for me the amount of meat or the amount of animals that I will need to sacrifice to produce, to attend this production or this demand. I'm sorry for those who don't feel comfortable with the word sacrifice of animals, but this is the example that was presented. And as I said, this is only to show you like how sometimes a very simple forecast and demand spreadsheet can help you to deal with the just-in-time of delivery of goods and also the stock and warehousing of it. So here in this module, the material and capacity planning is where things work, it's where things happen. And as I said before, here we're talking about everything that is made as the planning, and here is where the information from the bottom up reaches the reality of the top-down approach, and we say like, okay, this is what we are executing now. For each part, detailed plans show how many and when each must be made. This is again the maps that you have in front of you that shows you like the time schedule and how things will need to be done. Which machine is going to be used, which operator will be available, how they're going to work, how many shifts we're going to have, how many people, and on top of that, how many raw materials, how What is the amount of inputs that I need for my production? In theory, these things should be optimized, and we are going to talk about this soon. And here is where sometimes using simulation tools can help you to have a better view of what's happening in your process. As I said before, this level here deals a lot with macro data, and this level here deals a lot with the reality. How can we make both together, work together, and help you to support your production? I'm going to show you one example. I don't know how many of you have been in contact already with simulation applications, but in the simulation applications, you can have a clear view about your process in terms of how it happens without necessarily considering, let's say, fixed data. Here, this kind of simulation is where you can have the, let's say, you have inputs, macro data that says like, this is how many, the number of containers that we have as a capacity, and this is the amount of equipment that we have available to load a vessel. So now let's put together the data that we have in our database in relation to the productivity of this equipment, the availability of this equipment, the arrival of vessels, and the stock data that we have in our database. Let's match it together with the plans that the company has from now on and put them together inside a simulation machine just to see how it happens. So simulation, what I want to say is that simulation, it's not actually something that you use every day, but it's a much more used tool if you want to have a forecast, if you want to discuss a strategic plan. And I'm going to play this now just to show you, like, this is the arena 3D simulation. So you can set up this and again match your planning numbers with your operational data, which will give you a database to tell you like what can you expect in terms of how things will work. And it's very visual, very good for you to present, for example, to the board of directors of other people. But let me give you one example. In reality, I could see one mistake here that probably these guys that were presenting this solution were not able to visualize. When a truck does this movement in here, sometimes you have very strict rules in the seaport that nothing can go between the cranes, because if something moves in here and it's hit by the crane, you have an accident. Also, you have to consider, for example, that the radius to turn here is visible. It's something real. Why I'm making this comment? Because even when you do a simulation, if you don't really have the real knowledge about how your machine, how your equipment, how the rules work, you can be providing information that is too optimistic in terms of capacity, or you can be putting it down because you didn't consider constraints that you had in your process. But anyway, the simulation is a very good example of tool that can be used for you to produce a more visible forecast of your service, of your production. But on the other hand, it can be useful also to show you where you have the bottlenecks in your process. And I'm going to show you another simulation here from a packaging line. The same software, that's the arena, but this one is used in a 2D environment where you set up all your constraints and your equipment, And again, remember that I told you about the process mapping. So this is the process map. Each unit going through each one of the steps of the process is accounted. Here's when you have the line of items waiting for the next action. And you have the representation of your equipment here. And here in the bottom, you have the scores when you have a failure, when you have a bottleneck, when you have a problem. So everything can be visualized in this simulation based on, again, data that you bring from your planning together with the data that you have as input from your operation in terms of capacity, in terms of use of equipment, in terms of downtimes and other things. Okay? So this is only to show you the different types of forecasts that we can have. Main modules, coming back to the, well, do you have any question about simulation or planning or whatever? Just make it clear for me and I can stop and answer whatever you need. When we talk about the last layer here, this is exactly when we deal with things that need to be triggered by the planning process to happen. For example, coming back to the example of the car that I presented before, if you need to consider the different parts to be produced in your production line, you have to make sure that all the purchasing departments responsible for the tires, the steel plates, the cushion for the seats and whatever, they have the correct input to move forward with the production. The same thing is like when you need the production to be in place, you have to make sure that the information and the level of detail is enough for people to deal with that production. And in the end of this process, thinking about how we plan the delivery of the products, same thing happens with this part. Because, for example, you can have, coming back to some of the things that we spoke in the last lectures, you can have the in-source of your transportation, of your storage or whatever, but you can have also something that demands from you outsourcing extra workforce, or if you have the whole process outsourced in terms of logistics and delivery, you have to make sure that you are following exactly the contract standards that were established in terms of number of trucks, number of cranes, number of the amount of space available in the warehouse, to make sure that you are not overrunning or disconsidering some of these rules. So this is the moment where the planning reaches the other departments of the organization, and things are triggered and they need to work according to what you expect, or according to the master plan expect, and according to what the real production lines or the real production units can do. This is oh yeah, someone made a question. This image shows an upstream or a downstream. Which image? You're talking about this one here? A PPT. Yeah, so this is a downstream. I'm considering this as a downstream, as something coming from the top level to the down one, to the lower level, sorry. So this is all about the planning of the production and moving that across the organization until it reaches the execution level. All right? The differentiation between this and the, okay, so the differentiation between this one And the upstream is like when you have, again, the information coming from the operation, like the PLCs and all the other equipment data that is generated, going upwards to match the numbers. Let's say 1,000, it's my plan. This is what I think in terms of what I can do. This is what I'm asking people to do. When you think about the upstream, you're like, okay, this is what I am doing. So compare the data that is coming from my equipment, from my units, with what was expected in terms of material and equipment capacity. And please compare that with the plans that we have in terms of overall production according to the master plan. Now, let's talk a little bit about efficiency using just-in-time. And as I said before, just-in-time is something that we're going to have a much more, let's say, discussion approach than saying that this is the right thing to do. Because we have to consider some things when we talk about, just-in-time in manufacturing and logistics execution. Just-in-time is a broad philosophy that seeks to eliminate the waste and improve quality in all business process. Just-in-time, just to have you aware about the context of just-in-time. Just-in-time is a philosophy that was created in Japan. I am not sure about the year itself, but I think Toyota was the first company, manufacturing company, that implemented that. And the reason why it's important to mention Japan is because the country itself poses very challenging geographical and specific characteristics if you think about production of anything. Why am I saying that again about Japan? I'm saying that because if you think about just-in-time philosophy, sometimes you cannot actually have it applied to your case. Japanese people probably, because they had to transport things between islands, so they had to consider all the risks involved in this transportation, in the storage of these goods and things like that. They designed this as something like, all right, let's make sure that we have things on the right time, the right place, with the right quality. And somehow that was applied to them. The amount of companies that I've seen in my life that try to just copy the just-in-time philosophy in their production is so huge. And the number of times that I've seen things just not working was also so common that took me time to understand, like, if you think about just-in-time, you have to make sure that you consider your restrictions as well. For example, what is the point about thinking about there is a problem if you think about just-in-time and you say, like, every 5 minutes or every 1 hour, let's say 1 hour, a truck will be stopping here in my cross-docking warehouse, and another truck will come empty and will load the cargo that is being left by this truck. And this is how my system will work, because that's exactly how they did in Europe. This is exactly how they did in Japan. But what if I do not consider, for example, traffic jams and problems that I have in my own scenario, and later on I cannot comply with the just-in-time strategy? So this is why I'm telling you, like, although the just-in-time philosophy is something good in terms of thinking about eliminating waste, improve quality, and whatever, you have to consider limitations of your model. Some cases, for example, automotive companies, the manufacturing process only happens when customers, they request something. So in this sense, the just-in-time is, let's say, pushed in terms of production, and you only have the things working when you have an input, which is also something that you need to consider depending on your type of production. Another example, if I'm thinking about iron ore that is being transported from the mainland to the coast in Australia, although I'm not talking about just in time in terms of hours or minutes, I might be thinking about just in time in terms of days. For example, to form a pile of iron ore that will go into the vessel, I want to match the time that the vessel arrives with the time that the pile is formed and dried to be loaded into the vessel. So I'm using this example to say that just in time it cannot be a philosophy in your mind that talks about seconds, that talks about minutes, that talks about things happening in a very fast pace. The just in time is actually you having the right thing on the right place on the right time. What that has to do with what we are talking here today in terms of e-logistics. This is something that you can clearly see when you have, for example, simulation tools running for you. This is something that you can clearly control and manage when you have your data of your production line available for you, because you can keep looking at it and say like, okay, I'm in the right pace, I'm in the right track. If something happens, you can estimate how long it's going to take to recover that, and or what is the impact that that's going to create in your supply chain later on. And again, the context where you are applying your just-in-time, because it cascades upstreams through the supply chain network, and then that will impact later on the other steps of your process that are working in a just-in-time. The main problem with just-in-time, and I want to say this now because we can discuss this with more detail later, but the main problem with just-in-time is that once you have a problem and your supply chain depends on that solution of that problem to keep working, if you don't have a backup plan, if you don't have a backup, let's say for example, the stock with a margin of things that you can keep working while you are out of production or while you are not receiving raw material, your just-in-time is not actually a just-in-time, it's a risk-in-time. Because, like you are matching the risks of interruption with the consequences, and you are saying like, this is the minimum or the maximum that I can afford if something goes wrong in terms of my just-in-time production. If we think what rules just-in-time, we are talking about we don't want to overproduce, we don't want to wait too long, we want to make sure that we can have reliable transportation scheme, and this includes like waiting or having things that prevent transportation to happen. Inappropriate processing. If you plan something to happen in terms of production, you have to make sure that that's the reality. Remember the truck turning under the crane. You can say like, well, I can move 100 containers per hour. But if you cannot make that movement and you have to drive all the way to the end of the quay and then come back, it might reduce your just-in-time forecasting, let's say 20% or something like that. You don't want to keep a lot of inventory, but as I said before, you have to keep in mind what's your buffer. You don't want unnecessary movements. But the main thing, and this is where the Japanese people made a very good just-in-time philosophy, very good just-in-time management in the past, is because they didn't accept the levels of defects that were produced in their production lines. Nowadays, this is something that everyone understands, but the defect itself is not just a problem that will create you more costs or more returning of products and whatever. Defect means that you're going to need to work again, redo things, which means that your capacity will be reduced as well. So by eliminating the defects, you are making sure that your whole process, imagine, even if you have the trucks, the vessels, or everything coming just in time, if products are not ready according to what was expected them to be like, it means that they will not be ready to ship, they will not be ready to be sold, and on top of that, you will need to produce more. So although your whole chain of just-in-time is working well, your process is the bottleneck that is preventing all the rest to work correctly. Yes, question. Justin is saying that he imagines that just-in-time relies a lot upon reliability. Where the less reliable the system is, the less likely it can be used. Correct. Now, using your example, Justin, if you have a database, and thinking now, Kiki, I think you were the one asking about the upstream or the downstream model. If you have the machines, your production information, everything detailed according to what people need to forecast their steps in the process, you have the right content, the right amount of information available. It means that you can have a clear view about your reliability. As I said before, and that was the question, like if I want to produce 2,000 pair of shoes, what is the availability of the machine that I should consider? Well, I should consider 85%, 70% because I have downtimes and breakdowns or whatever. If you can rely in the data that is provided to you in terms of how that thing is working on the right way, you can have a very reliable just-in-time strategy. And again, the just-in-time is not something like immediately done. The just-in-time has to consider this reliability, especially the lack of reliability as well. If you have a new machine, a new truck, a new equipment, it means that probably it will run in a more reliable way if you have an old one. Everyone here probably has this example very clear when we talk about cars. If you buy a new car, you don't expect it to present defects in the beginning of its use. But as soon as you start using that along the time, it's expected that you will have problems with defects and maintenance more often because the equipment is being used. So yes, it's about reliability. And speaking about reliability, let's say that we would have 3 layers to look at it. If I don't have defects, if my process is clean, lean, and I only do what I need to do, and I have a minimum of downtime, it means that in a second layer, I will have the minimum delay of my process, production, and service. And consequences, for example, can be deemed to be a minimum level of inventory. This is the thing that supports later on the strategy of the just-in-time. But again, I appreciate the word that was used. The main thing about just-in-time is reliability. Factors that affect just-in-time, we spoke about them through this discussion, but make sure that when you have your supplies being planned, oops. Yes, Mohammed? Oh, wait, someone made a question here. Yeah, well, one second now. Justin, this is the example that comes to my mind all the time. If we worked in an airplane company, would we be brave enough to fly in the airplanes that we produce? Because imagine the level of precision that these people need to have and the level of accuracy that they need to have in terms of making that happen. So I agree with you, like airplanes, car makers, and other things. Let's think about the International Space Station. Yeah, like how much precision in terms of defects must be considered in that. For luxurious production, customers don't care about the price and waiting time. The producer can adopt just in time. But just for commodities manufacturing, this strategy is unrealistic. As I said before, it all depends on how you, it all depends on the type of product or service that you are dealing with and the context of your production. I fully agree with you. Like, if you don't have that luxurious product available in that moment for someone to buy, you can have a competitor selling something similar or another store that has it available, and you're gonna lose it. You're correct. But again, for the commodities manufacturing, I wouldn't say that the strategy is unrealistic. What will change is actually the parameters that you have to consider. And this is the main message that I would like to deliver about just in time, because we are it's easier for us to think about just in time as the immediate result. It's something like, okay, I want it now, I want it all, yeah, like the Queen song. But actually, depending on how your time span works in your process, you might consider different moments that things need to be available, that things need to be there in terms of quality, but still you have your just-in-time parameter to define, like, this is what I can accept, this is what I cannot accept. Otherwise, you cannot control your cost or your physical inventory. You cannot control or forecast how many people or how many equipment you will need in your production and things like that. But again, it's all about thinking the context. It's not unrealistic for commodities. It just changed the context of it, sorry. Mohammed say, I think the worst one is overproduction because it is a defect in some system and also increase in inventory and transportation. But defect just focus on manufacturing, on a manufacturing model. It is one of the worst because it's the one that we can see, all right? I'm just telling this because people tend to think like, well, production is the most important part. But remember, if you don't have the other parts working correctly as well, you can have hidden costs that later on will affect your overall performance. So just make sure that you consider the others as well. The manufacturing one, the overproduction is the one that you can see, but make sure that you consider these hidden costs as well. So we spoke about delay and inventory interact. Oh, sorry. This is just a comment that delay and inventory interact with a positive correlation. If they happen to be like, if delay and inventory, they can come down to get, let's say, if they work in the same interaction, if one goes up and one goes down, and if both goes up and down, you can have consequences in terms of positive and negative, you can have positive and negative consequences to them. If you have less delay, it means that probably you will have less inventory problems, or in the opposite way, if you have more delays, you will have a higher problem with inventory and other things. So this is just to make a comment that they have positive correlation. Again, defects leads to delays, and machine downtimes need to be considered as well, except for those that you already know that will happen in your planning. All right. So even if you set like, okay, based on the supplier of this machine, I should consider 10% of the time idle for maintenance. As you start producing, you're going to see in practice how many times you have the defects, and you can update that numbers as well and that information in the system, even to define when is the just-in-time moment to buy a new machine or to replace a machine that you have in your system. One of the things is that process should be simple, and I'm going to show you, we're getting to the end of this lecture, I'm going to show you a video that's going to show you very well an idea about how just-in-time should work. And you have to make sure that the level of work in process is able to show you exactly what's happening by the time. I'm gonna give you one example about transportation and just in time. The common concept that we have about a container terminal is like you have a yard where you store your container or your goods. You have the quay where you have, like, let's say, one part of the coastal line that can be used for berthing the vessel and putting containers inside of it. Or you can think about a just-in-time model where you have the vessel located in open sea, where you can use both sides of the quay to load and unload vessels. So instead of having only one side, when you have the land side and the vessel coming this way, you can have, let's say, like a two-way. But the main problem is, like, as I don't have my containers close to me, as I don't have my the access to the cargo that I need, how can I make sure that, that operation is efficient in terms of just in time? Look what these guys are thinking, and imagine the amount of controls that are necessary, and the amount of planning, the amount of forecast that is necessary to make sure that this can work. And this is going to be a good example comparing the luxurious products with the commodities. All right, let me play this one. And I'm going to mute my computer.
When it comes to cryptocurrency trading, there's a place that gathers Ethereum,
Skyway seaports are intended for transshipment of cargo from rolling stock to tankers, dry cargo and container ships, as well as for passenger transit traffic. The volume of cargo reshipment is up to 250 million tons per year. The transit of passengers is up to 1 million people per year. The arrangement of seaports using Skyway technology allows locating them on a sea shelf with natural depths of 20 meters or more and distance from the coast of 1 to 10 kilometers. Due to the absence of coastal port infrastructure and the arrangement of the most efficient transportation routes, there is a significant reduction in capital expenses for construction and operational costs in comparison with conventional seaports. Construction of seaports using Skyway technology will improve the efficiency and safety of their operation, significantly reduce logistics costs, and decrease the cost of shipping.
So, as I said before, like, you see, instead of having the traditional design, having vessels in only one part, you could have them berthing in two ways. You could have the area used for the storage of containers being located far away. I think this is feasible, but again, we have to think about the context of it. Like, what if a container breaks down, a machine breaks down in here and blocks everything? Because especially when we think about containers, we're talking about vessels that stop in a port for hours. We're not talking about vessels that stop for days. Let's say 5 hours to load thousands of containers and unload on it. So if I don't know exactly what is the reliability of this machine, of this transport belt here, and how these things work, if I have a problem, it means that I'm not able actually to operate in this just in time. On the other hand, if I'm not able to operate in this way, it means that I have to consider other costs that I will have. For example, the use of the land, how much I'm paying for that. And instead of having 4 or 5 vessels berthed here, I would be like having only 1 or 2 in the traditional model. But in this sense, I'm reducing the risk of operation in another scenario as well. If I think, for example, countries where I cannot rely on the transportation modes that come across to the point to get to the port, I can say that my just-in-time strategy, it's more risky than effective in terms of giving me competitive advantage. I'm not going to explore too much the discussion about manufacturing, just-in-time in manufacturing here, because we have that done before. And we had also a discussion about how just-in-time affects inventory management when we spoke about inventory, especially in terms of cost, in terms of organization of your inventory, and also the location of goods that later on will be, how can I say, moved by those working in the warehouse. All right, this is what I wanted to share with you today. Let me see, someone made a question here. So at every stage of the supply chain, just-in-time must be maintained till it reaches the customer and deliver. Otherwise, it is risk in time. Correct. Correct. And again, I want to say this thousands of times. As Mohammed said, if you look at the manufacturing moment step, it's the one that you have the visible impact in front of you. If you produce something with defect, if you produce something wrong, it's in front of you. You can see that. But if you don't consider what happens, for example, you can have a huge, well, we are talking about this now, all right? People are talking about the vaccine for this coronavirus thing. We can have the production of this vaccine, let's say in 6 months, 1 year time, but making sure that this is produced and distributed to who needs it, it's one of the main challenges of the just-in-time. Even if people are successful producing it, and let's cross the fingers that they will get to this point, we still have to think about how can we make sure that the just-in-time happens to make sure that these things are distributed correctly. I'm not even going to say that they are produced correctly, because if they are not produced correctly, we have a huge problem, and this is where the visible part of the manufacturing problems with just-in-time occurs. But if we don't have also the other steps, like the supplies coming through for the production and the delivery being done according to what is expected, that's a problem to the just-in-time as well. So this is something that we have to add in terms of risk in time as you move the process. Can I say that just-in-time kind of strategy with producing at the correct time, correct place, with correct suitable materials? Yes. As I said before, these are exactly the main principles of just-in-time. What I would ask you to think about is, now comes that kind of comment like, what if I wanted to ask this kind of thing in the exam, I would like you, for example, to explain to me what would be the problems that could occur in terms of correct time, in terms of correct place, and whatever, in relation to the context of your production. If I give you, for example, the example of the vaccine, how would you, Kiki, be impacted by these problems that are the main principles of just-in-time in here? It would be easy for me to ask you in the exam, like, tell me what are the principles of just-in-time philosophy, and you would say correct time, correct place, and whatever. But I would love to see, for example, how can you apply that in different production contexts. Doesn't matter if it's a luxurious product, doesn't matter if it's a health product, or doesn't matter if it's a commodity. But I would like to see you explaining how this applies and what would be your mitigation in terms of information exchange and process control to make it happen. Justin, he says, it's not just a risk in time, it's also a risk in business and a risk in trust. Yes, one thing, Justin, that you have to keep in mind, some markets and some customers, they are more strict about what they expect than others. All right? In my country, in Brazil, people tend to make fun about products that are made in China, saying that they are not reliable, they're not good, or whatever. What I've learned from my experience, especially working with heavy equipment, is that it all depends on how much you pay for that. So let's say that just-in-time can be something risky for your business if your customers, if the market that is consuming your good, it's quite competitive and strict about the rules. Let's say again the example of luxurious products. If you don't have this here now in this quantity for sale, we are going to lose sales. All right, this is one case. But you know, if you are in a country where people, let's say, don't even have access to mobile phones, it doesn't matter if you have a iPhone 11 or whatever available, and if you have that on time, it means that, you know, whatever you have there in the lower quality might sell as well. So it's not actually a risk to the business. The other thing is, like, you might need something for you that is not urgent. So in this sense, the just-in-time doesn't become a risk for your product or for your business. But again, if you're talking about things that save lives, or they are products that need to be consumed in terms of how do you call that? Instead of use, people that buy because they want to possess the thing, then it's a risk for you. And I think this is the main message that we need to have in mind about using of information in logistics, in manufacturing, and talking about just-in-time. We must consider the context of our products, of our process, to make sure that we are setting the just-in-time rules or parameters with what we need, because we don't want to push the system too hard for something that we don't actually need, but we don't want to be too relaxed as well, in a way that this creates a problem to our production, or our transportation, or our services. All right? Any other question? No? All right. I will stop the recording now. I appreciate all of you